In this video, we're going to go over stretches. There's two important things. So one is a vertical stretch of a function. So if you have f of x with a known graph, then a f of x is a vertical stretch so a f of x is a vertical stretch by a factor of a parallel to the y-axis with an invariant x-axis. So basically what this means is that whenever you have a times f of x, then you're going to multiply all your y values by this factor a without changing your x-axis. And then we have something called a horizontal stretch. So a horizontal stretch is when you have f of x has a known graph, and then you have f of bx. So here the factor multiplies x, right? So f of bx is a horizontal stretch. Now instead of the factor being b, the factor is 1 over b. So by a factor 1 over b parallel to the x-axis. And your y-axis is invariant. And that is everything. Alright, so a vertical stretch, you have f of x with a known graph. A f of x is a vertical stretch by a factor of a parallel to the y-axis, and the x-axis is invariant. If you have f of x is a known graph, f of bx is a horizontal stretch. The factor is 1 over b. It is stretched parallel to the x-axis with an invariant y-axis. So those are the two things that you need to take a note of. And with that, we can start doing our questions. Alright, so let me turn on my laptop real quick. And we can start. So the diagram shows the graph of y is equal to f of x. So I'll do the first one in light blue. So I need to sketch the graph of y is equal to 3 times f of x. So if you remember, this is a vertical stretch. This is a vertical stretch. Factor is 3 and then invariant x-axis. So I change nothing on my x-axis. I just multiply my output y values by 3. So I have minus 2, I have 2. So when I multiply by 3, I get 6. Here I have 1, right? This is 1. So I multiply by 3, I get 3. So these outputs are going to be here. It's going to go up. The shape of the graph will not change, right? It's going to go up. This is 1, so it's going to go to 3 again, like this. I'm sorry about that. So let's connect it properly. Okay, I don't know why it's not connecting. That is bad. Alright, so 3. Something like this. Alright, that works. And now 0 times 3 is still going to be 0. So it still passes here. Minus 2 times 3 is minus 6. You have minus 1. So that is going to go to minus 3. So when you multiply by 3, your graph looks something like this. So this is the graph of 3 f of x. Alright. And now I'll do the next one in red. So this is a horizontal stretch. The factor is 1/2. The y-axis is invariant. That means do not change anything on the y-axis, but halve all your x values. Alright, so 0 halved is still 0. 2, I have negative 2 2 comma negative 2 is a coordinate, right? So I want to do not change your y value, but your x value has to have, right? So I will have, instead of having this, so this is 2 comma negative 2, I do not change the y value, I will change my x value. So instead of 2, I will have it, because the factor is 1 over 2, right? So when I multiply by 1 over 2 to my x coordinate, I get this. And the same idea here. And so when I had 3, I had, this is 1, right? So I do not change the 1 value, but my 3 is going to start at half of negative 3. So minus 1.5. So somewhere here. And yeah, basically you just take some points, you have it. The shape of the graph is not going to change. So my graph is going to look something like this. And then it passes through the origin like this. So now here, this point is 3 comma minus 1. So I do not change my y value, but I have my x value. So this is going to go to 1.5 like this. And the shape overall does not change. Just the x coordinates of all the points have been halved. So the graph looks something like this in red. So if you check the textbook, they stopped at this point, but it should be fine. It's okay to continue because the given function, it continues on. So technically it should continue, I guess. So yeah, that is about it. But I think they did not continue it because they don't know. So at 6 you have 1. So at 3 you should also have 1. And yeah, so we don't know, because we don't know the behavior of the function beyond 6, so we'll keep it until 3 actually. That is better. So we don't know how the function behaves beyond these points. So this is what the function is going to be stressed to. So at 6 I had minus 1, 6 comma minus 1. So this extreme endpoint, I have my x coordinate, I get 3, which is here. And the same goes above here. So I cannot extend it actually. Okay, I'm so sorry about the first one. So yeah, all the x coordinates have been halved. My function looks something like the red one. And let me just erase these points to avoid confusion. So the graph looks something like this. So the red graph is for f of 2x. All right, and that is it. That is how you do it. So you can't extend this beyond. I made a mistake at the first time. You can't extend this beyond because you only know your function up until x is equal to 6. And that coordinate transforms to x is equal to 3 for f of 2x, right? So you just stop here. You don't know what happens, the behavior of this function beyond 6. So you just stop here. All right, so we're done with 1, A and B. And question 2 says, find the equation of each graph after the given transformation. So after stretch parallel to the y-axis with a stretch factor of 2. So that is just 2f of x. And f of x is just 3x squared. So just 6x squared. All right. So this, after stretch parallel to the y-axis with a stretch factor of 3. So 3f of x. That is going to give you 3x cubed minus 3. All right. So we're done with A and B. This is after stretch parallel to the y-axis with a stretch factor of half. So that is just half f of x. All right. So that is half 2 to the power x plus 4. And if you simplify, you get 2 to the power x minus 1 plus 2. All right. So this, after a stretch parallel to the x-axis with a stretch factor of 2. So that means if I'm stretching with respect to x-axis and my stretch factor is 2, then that means that b is equal to half. So I'm looking for half of x. Only this way I get a stretch factor of 2. If I had 2x, then my stretch factor would be half. Remember that. So f of half x is going to be 2 half x squared minus 8 half x plus 10. Sorry. And that gives us half x squared if you simplify, minus 4x plus 10. All right, we're done with 4. And then finally, so stretch factor is 1 over 3. So this is just going to be f of 3x with respect to the x-axis. So f of 3x is going to be 3x cubed minus 36. 3x is going to be, now what's 6 times 27? So 162 x cubed minus 36 times 3 is 108 x. All right. So we're done with question 2. And now question 3. So if you check carefully, if you see this is f of x, this looks like f2 of x. If you think about it, if you substitute 2 of x here, you're going to get this expression. So therefore, it's a stretch by a factor of, this is a horizontal stretch, so it's going to be half parallel to the x-axis. B. So if this is f of x, then this is just 3f of x, right? So this is going to be a stretch by a factor 3 parallel to the y-axis. All right. So if this is f of x, you're going to see that this is 2f of x. So this is going to be a stretch by a factor 2 parallel to the y-axis again, because it's 2 times f of x. And if this is f of x, then this is f of 3x, right? So you just substituted 3x instead of x. So this is going to be a stretch by a factor 1 over 3 parallel to x-axis. And that is it. And we are done with this topic. All right.